Good morning, everybody. In this video, we're going to be talking about two of the My Math Lab problems on that 2A assignment, number 9 and number 10. So just a reminder, folks, for the My Math Lab homework, a lot of times there will be applications thrown in there that we haven't explicitly covered in class, but anytime you get stuck on these applications, instead of using the Help Me Solve This, which uses some of your question attempts, you can always use the View an Example. So if you're getting a little stuck on an application or aren't sure what to do, that is a good place to start to see if you can figure it out on your own. So I wanted to talk about this one just because we will be talking about the midpoint formula later. We just hadn't talked about it by the time you got to this question. So in the first part of this problem, it says the radius of the circle whose diameter is along the line shown. So if this is the diameter, that means my center is here in the middle of those 2 points, and that my radius is this and this. So using the distance formula, which we just briefly talked about in the notes, the distance formula is square root of x minus x squared plus y minus y squared. And this is useful to me because if I find the distance between those 2 points, that will give me the diameter. And if I take the diameter and divide it by 2, that will give me the radius. So using those 2 points, we'll have x minus x. I'm going to do 7 minus 3 squared. And then plus 14 minus 2 squared. And that's going to be equal to, that gives me 4 squared is 16. And then 14 minus 2 squared, that's 144. So 144 plus 16, and then the square root of it, that is going to give me square root of 160. And that is my diameter, and hopefully your brain is telling you that that is not simplified, so we can break that down into radical 16. Radical 10, 16 is a perfect square, so that will simplify to be 4 rad 10. Excuse me. And so if I wanted to find my radius, I take the diameter and divide it by 2. So my radius would be 2 radical 10. All right, folks, so my radius as a simplified radical, so again, simplify your answer, type exact answer using radicals. My radius would be 2 radical 10. All right, so then the center, this is where we get into the midpoint formula. The midpoint formula is essentially just the average of the x's and the average of the y's. So my midpoint formula, I'll go ahead and do that up here, finds the point that is in directly the middle of that distance. So my midpoint formula is x plus x over 2 and y plus y divided by 2. So adding my x's, I get 10 divided by 2 is 5. Adding my y's, I get 16 divided by 2 is 8. So that would be the midpoint between those two, which is going to be the center of the circle. So 5, 8. So we've got our distance formula, we've got our midpoint formula. So now the equation of the circle in standard form is x minus 5 squared plus y minus 8 squared, and then equals my radius squared. All right, folks. Now, when I square 2 radical 10, that is 2 radical 10 times 2 radical 10, which is not a foiling problem because there's no adding or subtracting anywhere in here. So you just straight up multiply the coefficients, which gives me 4. Radical 10 times radical 10 is radical 100. So that would be 4 times 10, or 40 is equal to my radius squared. So that would be the equation of my circle. This part and the equals 40. So that is how you can use both the distance formula and the midpoint formula to solve this. Now, if you didn't know the distance formula, which I sometimes have a hard time remembering it, you also can use what you know about triangles. So if I think about this triangle distance, and I make that a right triangle, I can think about the x distance between 3 and 7, which would be 4. I can think about the y distance between 2 and 14, which gives me 12. And then I could use the Pythagorean theorem to solve. So 4 squared plus 12 squared equals c squared, which c is our diameter in this problem. And notice that we get 16 and 144, same as this, and then square root of it, that would give me C. So again, folks, don't get caught up in memorizing all these formulas, because a lot of times there are multiple ways of solving the problems using triangles or using your knowledge of the coordinate plane. You could also think of just moving in the middle of those two, which makes sense for finding the average. So hopefully that helps on number 9. Moving on to number 10. Now, 10 I explicitly wanted to go over because this is a great ACT type problem. So on the ACT, you do have to have some basic knowledge about circles. And the two formulas that you want to have memorized are area equals pi r squared and circumference equals 2 pi r. Now, I remember being a student and sometimes getting these two formulas mixed up. So if I think about area, like area of a room, that would be feet times feet or feet squared. If I think about circumference, that is the distance around a circle, which the unit would just be feet. So if you can remember that both formulas involve pi and r, and one has an exponent of 2 and one has a coefficient of 2, you can use the fact that your units have to be feet squared to give you the r squared, because if I put feet in for r and squared, that's how I get that area unit. Whereas with just a single r, measured in feet, that is how I would get just the feet unit. So for that one, the 2 isn't an exponent, it just goes out in front. So that's one of my tricks for memorizing those formulas for the ACT. So hopefully you were able to figure out the equations of those circles, just being careful always with the scales on my math lab, so making sure you're counting the appropriate units. So on problem D, it's asking for the shaded area. So if I want to find the shaded area, essentially what I'm going to do is take the area of the blue circle and then minus the area of my green circle and my red circle. So minus the green and the red. And since I am subtracting both of those areas, we're going to enclose that in parentheses. All right, so my blue circle's area, excuse me, would be pi r squared. So once I have the radius of that blue circle, which for my particular problem, it would be 2. So that would be pi 2 squared. Then minus the area of my green circle is pi r squared as well, and that circle has a radius of 1. So easy enough. That would be pi 1 squared. And then the area of my red circle also has a radius of 1, so plus pi 1 squared again. All right, so they say to leave our answer in terms of pi, so I don't have to get my calculator out. I don't have to get into the 3.14 business. What I end up getting is 4 pi minus 1 pi plus 1 pi. So 1 pi plus 1 pi. So 4 pi minus 2 pi is 2 pi. And that would be the area of just that shaded region. So that would be my final answer for that one, 2 pi. And again, your numbers are probably going to be different, but this kind of shows you the process for how to go about solving that problem. So again, folks, use the view and example if you get stuck on any of those applications, but this one I did want to explicitly go over as a class just because this is super important for the ACT.